All right, so here is the beginning of exponential equations. This background is so terrible you can barely read it on yours, so hopefully you can follow this. All right, let's go blue. Okay, so here is the first section, exponential functions. The problem here says if the population of a country is how much? 2.1 million. Just it's a big number of people. And it's increasing by what percent? Okay, 1.5% more people each year. What will be the population in 20 years? Don't try to give me an answer. Just kind of tell me, like, what would you do to get population growth? Yeah.
Well, I mean, you could multiply 2.1 times 0.015.
Okay, wait. Times what?
0.015.
Okay, like this?
Yeah.
Okay.
And then take that answer, multiply it by 20, and then add it back to the 2.1.
Okay, so you're just saying if I just take that times that and get the population growth, whatever it is, let's say it's 100,000 people more. And then I just keep adding another 100,000, 100,000, 100,000, right?
Times.
You know what he's doing? He's treating this problem as though it's linear. He's treating it as though if I add 100,000 people 1 year, then the next year I'll add another 100, then 100. So basically the slope is over 1 year, up 100,000. He's treating it as linear. It's not linear. It's exponential. So John, good guess. It's slightly up. You'd get close to the right answer, John, but you wouldn't get the right answer.
Would it be 2.1 to the power of 0.015 times 20?
No.
Or 1.015?
You're giving me a whole bunch of Okay, can I ask you this? Think next year. Just think next year. How many people do I have next year? His answer is not how many I have next year. His answer is how many people I add on to the original population. Harry?
Oh.
Okay. What I need the original 2.1 million people back. This times this is just the population increase. I want the original population to come back next year.
So you just add 2.1.
So you what?
You just add 2.1? Like
You could add 2.1 million onto it,
yeah.
but there's an easier way to do it. Like if I was doing it in my calculator, yes.
Is it 2.1 to the power of 1.5?
No. Okay, watch this, guys. What if I put a 1 here and then a plus? What's 2.1 times 1? 2.1 million come back next year. And then what's 2.1 million times this? Well, that's what John was saying. That's the population increase after 1 year. So if you type that in, go ahead, type it in. What's 2.1 times 1 plus 0.015? It's going to be bigger than 2.1, I can guarantee you that. Probably 2.315. What is it?
0.315.
It's 2.31 already? It grew that much? Wow. I don't think it's going that fast, is it? Is that what you got? That times that is 2 point what? 13? Oh, so you know what that is? That would be about 30,000 more people next year. Because that's 2,100,000, that's 2,130,000. So yeah, we went up about 30,000 people. But here's the deal. This new number, on this, that's after 1 year. After 2 years, wouldn't you take the answer times what? 2. Now this is the new population after 1 year. Well, a year now, if I go 2 years from now, it's this original times what we grew by. Now take the entire population right here and make it grow again by this percent. Would you multiply by what? This doesn't change, guys.
I think I got it.
Yeah, go ahead.
Would it be 2.1 times 1.015 to the power of 20?
Okay, now you're going to the final answer. Yes, it is. So here's what John figured out. If I want 2 years, then I'd have to multiply the original 2.1 times this. Whoops, I forgot my 1 here. Times this again, that'd be 2 years. What would 3 years be? Times this again, right? That'd be 3 years. So what's 20 years gonna be? The original population times the growth rate. You're growing by this percent. Why do I have to have the 1 there?
Because we're adding on.
So you get the original.
I gotta get the original population back. 2.1 times this, that's 2.1. I get the original population back, plus I get what else? Another 1.5%. So this is gonna happen for how many years? 20 years. This is what you're doing today. This will be one of our last slides, by the way, but this is it. And that comes out to about how many people? Type it in. How many million people? 2 point what? You say 83?
Yep.
So you're up around 2,830,000 people. So yes, we did grow. We went from 2.1 million up to 2.8 million, okay? All right, the next question says, when would the population exceed 3 million? Well, we're not over 3 million yet, and it's been 20 years. So now you're kind of down to this. Trial and error. So you guys, because you have no method to solve that, because you haven't been told how to solve it, give me some possibilities. This is what you're looking for right here. 25. I think 25 pushes you over, but too much.
24.
Try 24. See what we get you. 3.001 million. You just went over at 24. So at 24 years, you just sneak over the 3 million mark. Okay? Now today you have no way of solving that problem other than trial and error. But as I move on through this chapter, that problem, it will be so easy for you to get the answer because there's a way to do it. Okay? All right. Now, the lesson actually starts right now. All right? Here we go. All right. Definition of an exponential function is this. The exponential function f with the base a is denoted by that. Y equals a to the x, right? Okay. Here's an example of what you could see. Y equals 3 to the x. That's exponential. What's in the exponent spot? A number or a variable? Yeah, so what's new to you? What's new is the exponent is now a what? Yeah, the exponent is now a variable. This is what is new to you. Okay? All right, where a must be greater than 0. Where's a? Right there. And notice a lot of people don't know this, but that number is called what? Ooh, somebody said it. It's called the base. This is the base number. So where's the base over here, guys? 3 is the base. Okay. Where a must be greater than 0. So this number has to be bigger than 0. Can't be negative. Can't be 0. A can't be what, though? 1. Oh, why not? That would be your look if a was 1. Why can't a be 1? Say again. 1 raised to any power is always going to be what? 1, and this is not exponential. It's what? This is a constant function. It's a flat line. It's just linear. Okay? So you can't let a be 1. And x, right here, x, can be what? Any real number. Anything. Except imaginary. It's just real. Okay? Here's you trying to figure all this out. Let's go. I got a bunch of problems down here. They're all exponential. Would you please try to figure some of them out? Some of them you need your calculator. Some of them you can do it in your head. How about this first one? Is this a calculator problem or is this in your head? It's in your head, right? By the way, I'm going to write this differently. I'm going to write 9 to the 1/2. The reason? Because you're supposed to know what the fractional exponent means. What does the 2 mean on the bottom? This 2. This is the root. Okay? What does the 1 mean on the top? This is the power. Okay? So when you write 9, you write 9. What root are you looking for? Square root. Now, you don't have to put a 2 in there, but that's what it is. And then the power, where do you put the 1? Where?
On the 9.
On the 9, you can. Or you can do this. You can put the 1 out here. Really doesn't matter. Okay? Either way you do it, what's the square root of 9? 3. The answer is 3. Easy. Now some of them are just extremely easy. What's 4 squared?
16.
Okay, that was pretty easy. This one is easy if you just take your time. 2 to the 6. Ready? 2 to the first. 2. Square it. Cube it. 8. 4th power. 5th power. 32. 6th power. Yeah, you guys, sometimes you can just think them out, right? Here's one you can't think out on your own. It's 4 to the what? Pi. Go ahead, type it in. That's a tough one. That's an approximation, by the way. 70 what? 8. Okay. Good. All right. But look at the bottom 3. Which one do you need your calculator for? Square root of 3, or 3 to the square root of 3. Yeah, you need your calculator on that one, don't you? What's 3 raised to the square root of 3? 6.7.
Speak up.
6 point what? 6.7. Okay, 6.7. Okay, there you go, guys. Good. Let's do this one. Be careful because you might have forgot your rules for exponents. When your exponent is negative, do we like negative exponents? Not at all. So what we usually do is this. We change negative 3 to what? Positive 3. And you can't just do that unless you do what? He says take the reciprocal of the base. What's the base? 2 over 1. So it's what? 1 over 2. There it is. So it's 1/2 cubed. And again, you don't need your calculator, do you? What's 1/2 times 1/2 times 1/2? 1/8. Sometimes you guys have to start trusting yourself. Quit using your calculator. Because all your calculator is going to do is give you what? A decimal answer, which is so meaningless to you. This is pretty meaningful.
Decimals are the best.
Okay? All right, continue. Do you need your calculator? No. When you write 8, what is this again? What root? Third root, cubed root of 8. What are you going to do to your answer? You're going to square it, I hope. Right? What's the cube root of 8? 4. No, not 4.
2.
It's 2. But then you're going to square it and get what? And you probably meant that was what it was. 4. Okay.
So you'll
Hey.
get the,
Yeah.
You get the same thing if you had 8 squared under the radical.
I'm going to do that right now. Here I go. Or you could do this. Cube root of 8 what? Squared. Well, that's, now what do you do first? 8 squared is 64, right? What's the cube root of 64? It's 4. So it works either way, but sometimes this is the easier way, sometimes this is the easier way. Which way do you like? Which way did you like on this one?
The first one.
That one? I do too. It's easier. But sometimes this becomes the easier way. It just does. Okay? Questions? Next, plot enough points to sketch this graph, okay? This graph is right here. And I'm going to rewrite it as y equals 2 to the x. If you don't know what these graphs look like, you should start by using tables. Okay? And of course, there are easy numbers to try. What's probably the easiest number out there? Easier than 1.
0.
Okay. So you put in 0, you get what? Everybody agrees 1. Do you guys know there's a property? It's called the property of 0. The exponent property of 0. Any number to the 0 power is what? 1. What's 10 to the 0? What's 100 to the 0?
1.
Yeah, it's always 1. Okay, so it is 1. And then I heard people say 1. Put 1 in, what do you get? 2. Put 2 in, what do you get? 4. So, it's not that hard to put these in. You do want to get a couple negatives in there, like -1, -2. Okay, and if you did that, 2 to the -1.
0.5.
No. Yeah, tell me how to do it though. Don't you switch it to +1? Flip the base, it's what? 1/2 to the first, which is 1/2. Okay, what about this one? 2 to the -2? You're going to do what? Flip it. What's your answer? 1/4, yeah. So 1/2, 1/4. Gotcha. So quick sketch it and see what it looks like. I've got that look right now. If I threw in 3, let me quickly do it. If I throw in a 3, what's the answer? 8. 5, 6, 7, 8. Right here. Here's 8. Okay. So you can see this thing is growing really fast. But on the back side, what happens is I get smaller and smaller and smaller with my x's.
Closer and closer to the x.
Does it go below the x-axis?
No.
No. All it really does is it gets really tiny. So it rides on top of what? The x-axis. Doesn't that sound like something? It is, what's this line called? Y equals 0. Is your what? What asymptote? All right, there you go, guys. Y equals 0, it's your asymptote. It's your horizontal, okay? All right. And by the way, every one of these happen to be kind of the same thing. Let me just kind of show you what I mean on the next slide. See that? Y equals a to the x? That's what you just did. The graph of y equals a to the x when a is what? Larger than 1. This is given a name. It's exponential what? Okay, guys, this is growth. Right there, that's growth. The domain will be what? All real numbers. Why? Because every x what? Gets an answer, doesn't it? Doesn't every x eventually get an answer?
Yeah.
The range will be what? Only y is greater than 0 because, look, that y came out, that y came out, that y came out. Only y's that come out are what? Bigger than the asymptote, 0, right? That's why they said that. There are no what? There's no x-intercepts. Why? Well, it never touches, but you're supposed to say because there's a what? Because there's a horizontal asymptote where? At y equals 0. It won't touch y equals 0, which is the x-axis. Okay, horizontal asymptote. Well, I just talked about it. The y-intercept is always going to be what? Hey, is that true? So look. Put 0 in, what do you get? 0, 1. Okay, let's do this one. 5 to the x. Put 0 in, what do you get? 0, 1. Guys, every time you do this, 0, 1 is on your graph. Okay? Your function is increasing, and it's 1 to 1. Increasing because it goes up. 1 to 1 means, 1x for every one. Well, there's 1x for every y. Here's what it means. 1 to 1 means it passes the vertical line test and it passes the what? Horizontal line test. So if it passes both tests, it's known as 1 to 1. Okay? The graph is always contains what points? 0, 1, which we just talked about, and what? You listening out there? 1 comma A. What does that even mean to you? It should mean this. You put the 1 in, you get what back? A is the base. So what would your answer be here? 1 goes in, 3 comes out. What's your answer on this one? 1 goes in, 10 comes out. Guys, you don't even have to think. It's right in front of you. All right, the graph is smooth and it's continuous. It doesn't break up on you. Okay? I think I'm done. Next. How does the graph of this compare to this? How does that and that compare? Well, let's quick get some points here. X, Y. Okay? Easy numbers. 2 easy numbers to plug in are
0 and 1.
0 goes in, 1 goes in. So what's the answer for this one?
1.
What's the answer for this one, Jeff?
2.
1 goes in,
Oh no.
1 half to the first. 1 half. 2 goes in, Lauren, what's the answer? Put it 2 in, it's 1. 1/4, there you go. Let's quit with the positives. Let's go negative and negative. Okay? If you put a negative 1 in, you get 1 half to the negative 1. But you're not going to do that, are you?
2.
You're going to flip it and go 2 to the first, aren't you? Which is what? 2. 2 to the negative second. Go like this.
4.
Make that a 2. And now you're at 4. There you go. Alright, so here I go. 0, 1. I've got 1, 1 half. I've got 2, 1/4. I've got negative 1, 2. I've got negative 2, 4. Okay. So what do you see? Comparing these two. This compared to this. You guys remember what this even looked like?
Yeah.
This was here, wasn't it?
Goes after there.
They're not opposites.
It's reflected across the line.
They're reflections, aren't they? So these are what? Reflections over what? Over Y. Which one's growth? Red or blue? Red's growth. Which one's decay? Blue. Okay, this is decay. And you have to know this goes on forever up. What's this do?
Rise to X.
It rises the x-axis, which is y equals 0, by the way. Okay, it's a horizontal. I think the bottom just talks about it a little bit. And it says, the graph y equals a to the x when a is between 0 and 1 is known as what? Decay. Has all the same properties as when a was greater than 1, except what? It does what? It decreases rather than increases. That's what it does. Okay? So this is the look of decay. Decay just kind of goes down here, right? Good? Okay, just take a look at it and see what this says, and that's what I'm trying to get that across to you. Okay, part of your assignment is going to be transformation. Okay? Guys, transformation was taught in Algebra 2. It was taught in 1.7. We're in Chapter 3 now, so guys, you got to think like this. Using the parent function y equals 3 to the x. Okay, right there. Would you say that is growth or decay? Okay, growth. Okay, if it's growth, you kind of know what it looks like. It kind of looks like this, doesn't it? So give me 2 good points, just 2. 2 easy points.
0.
0 what? 0, 1. Give me another one. 1 what? 1, 3. You know it's growth, so you kind of know it does this, right? You with me? This is 3 to the what? X. What are you graphing? You're graphing this. This is your new function. Okay, we've done this several times. What is this going to be? Okay, it's not 3 to the x, it's 3 to the x minus 2. So what does this mean? Inside grouping symbols means what? Right 2. So you're going to go where? You're going to go right 2, period. Okay. Now it does not say 3 to the power of x minus 2. It says negative 3. The number in front, the multiplier is what? You guys see a number in front of me? I do. Negative 1. It's negative 1 times 3 to the x minus 2. Now the 1, is that a stretch or is that a compression? Or is it neither? Neither. What's the negative do? That's a reflection over what? That's a reflection. Spelling everything wrong. Reflection over what? X-axis. Okay. Okay, so if that's what it is, let's just do it one at a time. Right 2, reflect over x-axis. So where am I going to go? Right 2. Now I'm up 1. Now when I reflect it, I'm what? I'm down 1, right here. Move right 2, right there. I'm up 3. Now I reflect it, I'm what? Down 3. Okay, do you see this graph going up forever? Guess what yours is going to do? It's going to go down forever. Now we got to talk about the horizontal asymptote. Ready? This point right here, pick a point. Just pick a point on it. Move it where? Right 2. So I go right 2. Then I reflect it. How do I reflect it? Over the x-axis? It's barely above the x-axis. Where's it going to be? It's barely below. It's right here. So you kind of know it goes like this, this, and then it shoots this way, right? So there is negative 3 to the x minus 2, right there. I suppose I could do that. Good? So just do what you did in chapter 1. It's the same thing. All right, here, quick. I want this. What's this going to look like? Who wants to tell me? 3 to the x minus 3 in the back. Down 3. Okay, well then move this parent down 3. Where does this go? 1, 2, 3. Where does this one go? 1, 2, 3. Okay, and you know it's just growth. It's going up. But here's the deal. What's the horizontal asymptote going to do? It's going to go down 3. So what would the asymptote be? Y equals negative 3. Good. So you said 1, 2, 3, right here. Y equals negative 3. So it would ride out on this one, wouldn't it? So the vertical asymptote, sorry. The horizontal asymptote will move up and down if there's a what in the back? The back of the parent. A plus or a minus. If you have minus 3, the horizontal is moving down 3. If you had plus 3, the horizontal is moving where? Up 3. That's the only thing that's going to control the horizontal asymptote. Okay. Now, when you start getting into story problems, the story problems typically have this number in it. Okay? For most applications, the natural exponential function is used. This comes in the form of e to the x. Now, the letter e is not a variable. This is a number. E stands for what number? That number. Just like pi stands for what? 3.14. And really that's what you guys know, but it goes on forever. Well, E is this number, and it's been programmed in your calculator. Okay?
How was E discovered?
I can show you, John, after class. I did it last year with you, and I'm not going to do it again. But I will show you, John. Okay? Now, guys, this is called, E is called the what? It's the natural base, and that's what they call it, okay? Now, E, like I said, was programmed in your calculator. You will use your calculator all the time except for a couple. It says here, values of e to the x are always approximations except if x is what? 1, -1, or 0. So do all three of these. See what you get. These are the only 3 times you don't need your calculator. What's e to the 0?
1.
That was easy. Because anything to the 0 is 1. E to the first.
E.
Just e. E to the -1 is
1 over E.
1 over e. There you go. That's about it. The rest of them, just type it in. Okay? For example, that one, I'd approximate. What's e times e times e? Or better yet, 2.178, or sorry, 2.718 times itself 3 times. 10? I don't think so. 20 point what? Was it about 0.09?
Actually, I
Okay.
would 20.08.
Now what I was doing there was I was just trying to make you find the button. If you don't know where the button is, guys, you'll just be guessing the whole time on your homework. Gotta know where the E is. Okay? And every calculator is a little different. Okay. All right. Now we get into solving equations, exponential equations. There's one type of equation that's pretty simple. It's this one. Special cases that make exponentials very solvable are anything that follows this property, 1, 2, 1. But to me, 1 to 1 means this. If you have a base number raised to a power of x and a base number raised to a power of y, and these two base numbers happen to be the same base number. Now watch this. If that base is 2 to the x and this base is 2 to the y, what do you know about x and y? They have to be the same. So the exponents must, come on over here, must be equal. So if you're ever looking at an exponential equation and the bases are the same, then do what to your exponents? Set them equal. That's it. Okay, here's your first problem. I'll write it a little bigger. It's 3 to the 2x minus 1 equals 3 to the x plus 2. Solve that equation. Tried to show you up there what to do. If your bases are identical, then your exponents have to be what? Equal. They have to be. So when will 2x minus 1 equal x plus 2? You probably solved it by doing this, right? Move that over. You got what? X minus 1 equals 2. Better yet, come over here. Better yet, x equals what? 3. How do you know you're right? Plug it in. This would be what? 3 to the 3 plus 2, 5. This one would be what? 3 to the 2 times 3 minus 1, 5. It works. Right? That's easy. Why? Because the bases were what? The same. So what happens when this happens on your quiz? And you get that? 5 to the what? X minus 4 equals 25 to the what? X plus 1. So what are you going to do? You can't set them equal yet.
Oh, you have to change the 25 to 5 or change the 5 to 10.
Okay, you got to have the same base. Either you got to have 5 to a power equals 5 to a power, or 25 to a power equals 25 to a power. Skylar, she's already saying it. Make this what? Make it base 5. Change it, guys. Just change it. 25 is really just what? 5 squared. This one I'm not going to change. Right? But wait a minute. This is 25. Now you called it 5 squared, which is still 25. Still has to be raised to what power? X plus 1. Do you guys remember your rules? And when you take a power and raise it to a power? That's multiply, yep. 2 times x, 2 times 1. 5 to the x minus 4 equals 5 to the what? 2x plus 2. There you go. Solve it. You have the same base. It should be really easy now. X equals what? Right? Yeah? That's it. You can check it. I'm not going to take it for time. There you go. Try that one. It's the same kind of problem. Make your bases the same. You can't do it right now, guys. Okay, once you get it, show me. Period 4, 1 student got it right. Period 5, 3 students got it right. Period 6, what's going to happen here? So you went, okay, wait. 8 is 2 cubed. You didn't multiply the 3. One person has it. Wait, go back. Anybody else have it? Yep. Okay. Now I gotta show you this. That there's multiple ways to do this. Did anybody change them to base 2? There's a 2. There's a 2. There's a 2. 2. Okay. What'd you change yours to? Yeah, what's your name? What? 2. Oh, you did 2. Okay. So let's do this, guys. This is what they did. He changed, well, they all did. They went 8 is 2 what? Do you guys agree 8 is 2 cubed? Yeah. Okay. But then he has an x plus 1 on it. Okay. How do you change, listen, how do you change 1/2 to base 2? 2 to the what? -1. Okay. Which would give me this. 2 to the -2x equals 2 to the 3x plus 3. There. That is what they did, and all these people got it right, and then they just set their exponents equal to each other, solved it, and got x equals, help, without showing the word. -5 what? or negative 3/5. Gotcha. Okay. Now, that's one way to do it. Did anybody do this? Did anybody change it to 1/2? Because this one's already 1/2. How can you change the number 8 to 1/2? Negative what? Ooh, not negative 4.
Three.
Yeah, if you went like this, 1/2 to the negative 3, if you flip the 1/2, you get 2. 2 cubed is 8. You got it. So what you could have done is this way, and you get this. But that answer, once you set them equal, is still that answer. It's up to you. Okay. All right. That's a hard one, by the way. Here's some quick applications. We're only going to get through one more slide. This slide, you just need to know what everything stands for. So whenever you do money, when we're talking about money, we need this formula right here. Okay? Now P, what you need to do right now, guys, is write this down. This is your original investment. Okay? The letter R is known as the interest what? Rate. The letter T, that's time, measured in what? Years. Hang on, they're too loud. The letter N, this is not a fun one. N is the number of times your money, the word is compounds. And it would be yearly. Let me say this, per year. Okay? Do you understand when you go to the bank pays you how many times per year? Twice a year. No? Once? No. 4 times. So the word for 4 times is quarterly. So if I say you're getting paid quarterly, you know what that number is right there? 4. Okay, this end goes with this end. Okay. Now, if I say monthly, you're getting paid monthly, that number is what? 12. Okay. Now, here's the deal. That's money. But most things, when you talk about story problems, don't grow every month, every day. They grow every instantaneous second. Not even a second. Shorter than a second. That's known as what? If something grows continuously, I always use hurt. E is that number we talked about, right? Now, P, R, T are the same up here. Okay? So P is an original investment. R is interest rate. T is time. E is just a number. Okay. Yeah, I wrote it original. Okay, I think we're ready. Here we go. Let's see if we can get this slide in before the bell rings. Calculate the amount of money in an account that started 5 years ago at $6,000, which has been earning interest at 3%. Compounded what? Continuously. That's PERT. Okay. Well, how much money did I invest? $6,000 right there. Times what number? E is a number. Use your calculator. What's the interest rate? 3%. 0.03. Times how many years did I leave in the bank? 5. Okay. Just let your calculator do the work. Okay. Your money turns into how much? 900 what? 70 and a penny, right?
Yeah.
Okay. All right. You see this big A? This big A stands for the final amount. I didn't write that on the previous slide. I forgot. Okay. Last one, and this is it. What if your money compounds, which means you're getting paid this many times. How many times did you get paid?
4.
4. Now you gotta go with this formula right here. 1 plus P times 1 plus R over N to the NT. So let's stick some numbers in. What are we putting below the 0.03? 4. Exponent 4. How many years did you leave it in there? 5 years. Type it in, just as you see it. I probably would change that to 20, just to shorten it up.
6,967.
6,000 what?
967.
967 and
1 cent.
10 cents?
No.
Okay, 10 cents, isn't it? Alright. Sorry I did that awfully fast, but we were running out of time, and that's what I had to do. Now the next slide is about exponential decay, and I don't have time to do it with you, I'm sorry. It's in your assignment, you probably have one problem on decay. Okay? Yeah, go ahead.
Okay, isn't it just 70 cosine?
It's 1 minus. It's 1 minus. Okay guys, here's the deal. You took a test Friday, 5 of you did not. I'd like to know when you're coming in. And the rest of you, it's out of 55. 55 points. If you want your score before you leave, I got it. If you don't care about your score, you can look in 2 or 3 hours, it'll be in PowerSchool. Out of 55, here you go. Come on up. John, are you coming? Oh, okay. Hang on, John. I want to.
Did you want us to ask?
Whisper.
It's fine, whisper. Why don't you just look? Here. Okay. Okay. All right, anybody else? That's it? You guys want it?
It's later.
You can, but.
I'm coming in after school. I'm taking a test,
So
I
you
can't
can get that.
Mark
Out of
Harris,
55.
please come to the main office. Mark Harris, please come to the main office.
Out of 55. Okay.
I'll be in on Wednesday because I can't today and tomorrow I'm gonna have to do geology.
What time is it?
And Hunter Holverson, will you please come to the office? Hunter Holverson and Luke Kaufman. Thank
Okay,
you.
we're gonna do geology together.
But I have hockey tryouts right after school tomorrow, so
You guys don't start hockey today?
I do. That's why I can't get the exam.
Okay. So then, you're doing geology day tomorrow?
No, tomorrow I'm doing geology.
What are you doing today?
I have to run over my hockey stuff.
You forgot hockey starts today?
Well,
Just kidding, just kidding. Just go, just go. Let's see it. Hey,
I'll check.
hey, take that. Okay. But let's be ready, be ready.
I'll take it.
You're ready?
I'm good to go.
Right now?
I can be.
Oh, this isn't off.
Yeah.
Oh,
So I'm good.
yeah, I just didn't want you to have class or something.
I'm good.
Alright. You have hockey too?
Yeah, I have hockey too.
But it's like 3 o'clock or 4?
It's 3:30.
Alright.
I should be able to finish it.
Oh yeah, you'll be done, open by 2:40.
That'd be fantastic.
Okay.
Can I run to the bathroom quick?
Yep, do that. Okay. And there's really nothing I need to tell you, I don't think. I'll look at it.
Nothing that's gonna.
Yeah, nothing got changed and, no, I'll look at it for you.
Do we?
I will tell you this, you know that last problem?
Yeah. Do I get a list of the 9
That,
steps?
you can use it. No, you haven't.
I have it.
Yeah,
Yeah.
just take it out. And what I'd like you to do is kind of step by step go in order. Don't just have it all over the place.
Right.
It's hard for me
Label
to,
it.
yeah, it's hard for me to find it.
Okay. Do you want the study guide?
I do if you're ready.
Yeah.
I mean,
I'm done.
you done?
I think so. Yeah.
And that's it. There's really nothing to tell you.
All right.
Yes, sir.
Okay, I'm curious on how.
E came about?
Yeah.
Oh,
how-
it's kind of like this. So you know how it was always, you know, they talk about it's the original population times 1 plus whatever.
Yeah.
Well, it doesn't matter what that number is, so they just put a 1 there, and then they go, well, what happens if we just keep making this number, you know, yeah, bigger and bigger? Well, so we start with 10. I did this with you last year. So we said, what's 1 plus 1 over 10? And you guys would tell me it's 1.1, because this is just 0.1. Then they said, well, let's make it to 100, 1,000, 10,000. And they just kept doing it. And as you get bigger and bigger, the number on the bottom gets bigger and bigger. It approaches the number. And the number ends up being 2.71. It ends up being that number. And then they go, well, that
So it
number.
reaches a plateau.
Yeah, the plateau is what though?
E.
They call it E.
Okay.
And that's really where it came from, because the formula is always the same, 1 plus 1 over whatever.
Yeah.
And then we said, well, what happens if we just make the denominator bigger and bigger? So the number of times you get paid, if the number of, you know, because as you get bigger and bigger, you're growing continuously.
Yeah.
And then it continuously meant this is the number every time.
Okay. I was just curious, you know, I didn't remember from last year's.
So instead of going like this, P times this, they just like, well, let's just call this a number. What number? E.
Okay.
So it's P times E.
All right. Thank you.
That's all it is. Yeah, I talked to Seth this morning. So Seth and I did this, just so you know. Okay, right here, I put Seth and Ryan, November 7th. Okay. So here's what you guys have for tomorrow. Okay, so you guys are doing some kind of like put them in a group, right?
Right.
Okay, and I just said, Seth, what if we put it on a smart board so you guys can at least talk about it? You have it in front of you. So there's, I'm not quite sure how you're going to do it, but I think he said something like, we'll bring up a couple kids,
Yeah.
and they'll show what the equations were. Here's group 2, here's group 3, and then you're just, I don't know, you guys are writing the equations, and then you're recognizing what the slope is and how it's always opposite reciprocals.
Yeah.
Okay, then you start your lesson. So then we put your lesson on smart or notebook. And now you have it. So then you can work it out with it. Okay, and then I think this is the next page, example 2. How do I write equations for perpendicular lines? 1, 2, 3. And then example 3, example 4. Yep, there it is. You got it. It's all there. And then all the work you're handing them is right. I got it over here.
Yeah.
And he told me I don't know where it is. Oh, is it here? Oh, yeah, okay. Okay, anyways, so this is your homework. Okay, and I have graph paper. Okay, and then these are the slides. Now, he said just give me 4. Because I said, are you just going to give 1 per group? And then he goes, oh yeah, we could do that. And then, okay, so 1 per group is what he said. And I don't know if you're going to let them write on it. I don't think you will. Because you want to use this for period 2, I think, right?
Yeah.
Yeah, you're going to have to talk to him in the morning how he thought that through. Once he said he needed 4, I just said, okay. Oh, that's not right. That's not enough. Okay. Anyways, so you just want a copy of that? Or do you already have one? You have one? Okay. So anyways, that's your stuff. And then, so put that there, and then here's the assignment right here.
And you want to still come at
Oh.
7:30 tomorrow?
Oh no, you don't have, if you guys are good to go, if you know what you're doing, then I don't care. The only reason I said 7:30 before is because I never got a chance to talk to you, and it's just kind of nice, because I never knew what the lesson was. last time, you know. So I mean, he and I kind of visited, and then he said he'd take period 1, and then he'd pick period 2. So the good thing about period 2 again is you get to watch him do his thing. Hello, are we taking it?
Yes.
Alright, I will send them.
Okay. You're good to go, right? Okay. Okay. Okay, so, you okay? Do you want to give me slides?
Did you not have them in?
Well, you weren't here on Friday, so I think you did.
Yes.
You might have, I mean, you might have gone the day before, I don't know.
And this? Still these, right?
No, this was Thursday, and this was me just
That's just for.
keeping you kind of like on task. This is what we're doing tomorrow. You know, I didn't give you points for that, but I said hand it in if you want to. But if you don't want to, just keep it.
We have your points for it?
I was throwing them away.
Okay.
And if you keep it, you know, like here comes the semester test in January, you look at it and go, oh, I remember this. Okay, so you're ready to go?
Yeah.
Okay. I don't have to tell you anything? No reminders? You don't need any reminders? Okay. Wait a minute, you're not period 4, are you?
Yeah.
You are period 4. There you go. There's really not much to say, other than, I will say this, that last one, you can use your 9s sheet, you know, this is worth 8 points. So just when you start doing it, it'd be nice if you said, number 1, the domain is, number 2, is there a hole at this number or not? You know what I'm saying?
Yeah.
The more organized you are, the easier it is for you to find your work. 55 points. How's Maddie doing?
Yeah, I need to see my test.
Can you what?